The law of sines is what we are doing here. And the law of sines states that a side length divided by the sine of the angle opposite that side is equal to a side length divided by the sine of the angle opposite that side, which is equal to the other side length divided by the sine of the angle opposite. So the easy way to remember it, so A over the sine of A is equal to B over the sine of beta is equal to C over that sine of the angle opposite it. And as we're always dealing with the opposite side. Now notice that this doesn't have to deal with right triangles. The law of sines can just deal with any scalene triangle. All you really need to know is going to be at least we have to have the sine of the angle opposite that side is a name for all angles and the angles of a different triangle. So we do need a couple things. We need at least two angles and one side to do it. So we need at least two angles and one opposite side. So let's figure that out. Let's try a couple here and see how that looks. If I look down here, we have find BC. Well, you notice that we have the angle opposite. Now they're giving us this side 27 here, but we don't know that angle. Well, we can do that just by doing 180 minus these two, which is going to give us 90. This just happened to end up being a right triangle. It doesn't really need to be. I mean, we could use sine, cosine, tangent, all that stuff, but that's not what we're doing here. We're trying to do law of sines. So let's follow what they say. So in this case, we're going to take, we're going to deal with A here. So we're going to do this side divided by the sine of 39 is equal to 27 divided by the sine of 90. Okay, and then you calculate what those are, plug them in, cross multiply, you'll get your answer. All right, so let's go here to geometry R.11, law of sines. And again, let's look at their example just to see what they have. Again, they have the law of sines just like I showed you. And then just plug in, if you know the side opposite, the angle, the side opposite, and the angle opposite. It's just a matter of just plugging them in, putting the numbers in, and seeing what you end up with. Okay, so let's try one here. Notice they're giving us these two angles. So they want us to find G. So we can do G over the sine of 21 is equal to 17 over the sine of 141. So let's try that and just see what it looks like. So I'm going to change this to G over the sine of 21 is equal to 17 over the sine of 141. We'll check those, 141 and 17. Okay, now we don't really need this third one here. We could do it if we needed to, but we don't need to. So we're going to take that off. So let's plug in what we know. Again, we have G over the sine of 21. So I'm just going to see if I can copy this here. Don't need all that. Let's do the sine of 21, which is 0.3583. And 17 over the sine of 141. Which is 0.6293. All right, now we're going to cross multiply. So we've got 0.6293 G is equal to 0.3583 times 17, which is 6.0911. Now, if I divide both sides by what's attached to the G, in this case, I'm divided by 0.6293, and I get 9.679. Now, what are they asking for? Tenths place? saying the nearest tenth. So that would end up being 9.7 because the number next to the 6 is bigger than 5, or 5 or bigger. So 9.7. Okay. Let's see if there's anything else we should know here. So again, we would just set this one up. We could just do, it wants to find x, so that would be x over the sine of 31 equals 20 over the sine of 134. Plug in your numbers, cross multiply, and you get your answer. All right. Let me just see what the next level happens to look like here. So v, so we just have v over the sine of 134 is equal to x over the sine of 31. Again, same, pretty straightforward like we've done before. Let's just see if there's any other levels. It really doesn't seem to get any harder. It's just the same thing over and over again. So I'll probably just do a smart score of 50 on this one as well, because it's kind of repetitive as you go through the levels. So that should be it. Good luck.